Assalamu alaikum. This is Tamin Akhtar Prapti. My student ID is 222901002. Today our presentation topic is speed control of DC motor. Our presentation is presented to Shoroborwa Sir, lecturer and program coordinator, Green University of Bangladesh, and presented by MD Abdullah Rahat, MD Moinuddin, and me. Next slide, please. My first topic is the introduction of DC motor. A DC motor is an electrical machine that converts electrical energy into mechanical energy. In a DC motor, the input in electrical energy is the direct current which is transformed into the mechanical rotation. Next topic. Next slide, please. My second topic is DC motor construction parts. A DC motor consists of several key parts with specific functions. They are stator, rotor, brushes, commutator, windings, shaft, bearings, field magnet, or we can say field coils. Understanding these components helps explain the basic principles which a DC motor's operation. Next slide, please. My next topic is operating principles of DC motor. A DC motor operates by creating a magnetic field in the stationary part and passing a current through coils in the rotating part. The interaction of these magnetic fields produces a mechanical force, causing the rotor to rotate. The commutator ensures continuous rotation by reversing the current direction in the rotor coils. Brushes maintain electrical contact, allowing the process to repeat and sustain motion. Next slide, please. My last topic is types of DC motor. Based on the type of construction and electrical connection, DC motors can be categorized into four major types. Some of them are permanent magnet, DC motor, shunt motor, series motor, compound motor. This is again classified into short shunt motor, long shunt motor, differentially compound, commutative compound. Each type of DC motor has a specific advantage and is chosen based on the requirements of the applications, such as speed control, torque, and efficiency. That's all. Now I would like to request MD Moinuddin to continue our presentation. Thank you.
Assalamu alaikum. I'm Moinuddin, ID 222901001. Now my topic is the types of DC motor speed control. And there are many types of each, that is the voltage control, armature resistance control, and field flux control, pulse wide method, and copper control, and series parallel control, and electric drive system. Then we have to design a control DC motor control. Speed control of a DC motor simulator is for this simulator we can use a DC battery and the potentiometer and a DC motor. Then we can run this simulator. This controlling system of DC motor is controlled by the potentiometer and the DC battery. When the potentiometer value is increased and decreased, then the speed can be increased and decreased. And when the battery's values in increase and decrease, then the speed can be increased and decreased. Here is the total controlling system for this simulation. Then my next topic is armature voltage control. The voltage regulation of voltage source, there the speed of the DC motor directly proportional to applied voltage. Therefore, reducing the armature voltage shows that the motor and the increase the voltage speed up. The effect on back EMF. As the armature voltage reduce the back EMF electromotive force and generated, the motor also reduce the back EMF opposite the applied voltage. The influence the current flow the armature winding. Impact and torque. The armature voltage control the sensitive and application where the speed regulation and critical without the compromising and the motor's ability in deliver the constant torque. Energy efficiency. Controlling speed by the reducing voltage result in the higher current flow and leading the increased power losses and the heat and the motor. Then my next topic is the serial parallel connection in the field. The serial parallel connection in the field is the DC motor is always adjust the speed torque or characteristics. Initially connected the series in the field winding the upper high the starting torque showing the parallel configuration, providing the increase the speed with the reduced torque, offering the versatile.
Thank you, man. Myself, Abdullah Rahat, ID 221901060. Now I will talk about the flux control method for controlling the speed of DC motors. This can be derived as field diverter, armature diverter, tapped field control, and paralleling field coils. Field diverter diverts a portion of the field winding current using a diverter resistor, alternating the field strength to control the DC motor speed. On the other hand, armature diverter redirects a portion of armature current through a diverter resistor, adjusting voltage and speed in DC motor control. Tapped field control utilizes multiple taps on the field winding to change the field strength, allowing varied speed controls in DC motors. Lastly, paralleling field coils. It adjusts speed by connecting field coils in parallel, alternating the total field current and strength in DC motors. Next slide. Now I will talk about the Ward-Leonard method. It involves using an auxiliary motor generator set to control the speed of DC motor. The motor generator adjusts voltage and current, allowing the precise speed control. By varying the generator speed, it alters the DC motor's input, providing a flexible and reliable speed regulation for various applications. Next slide. Thirdly, I will talk about the rheostat control in DC motor. In DC motor speed regulation involves adjusting the resistance of rheostat in series with the motor's armature. By varying the resistance, the armature voltage changes, influencing the motor speed. While simple, it inefficient due to energy dissipation in the rheostat as heat, making it suitable for low power application. Next slide. Now, lastly, I will talk about the applications of controlling the speed of DC motor. DC motor speed controls finds applications in various industries, including robotics, manufacturing, and automotive system. It enables precise manipulation of motor speeds, enhancing efficiency and performance. Common applications include conveyor system, electrical vehicles, and automated processes where adaptable and controlled motion is crucial for optimal operation. So that's all from me. I appreciate the opportunity to speak with you today. Thank you.